9.3, solving quadratic equations. Solutions, roots, x-intercepts, and zeros. Oh my. All of these things pretty much mean the same thing. They use all these different terms for the same thing. So let's get started. Alright, so when we are solving quadratic equations, you're going to make sure that the equations are set equal to 0. If they're not, you have to move things around so that they are set equal to 0 and keep it in descending order. Once you have it graphed, the place or places where the function crosses or touches the x-axis, they are called the x-intercepts or zeros of the function. These same places on the graph are called the solutions or the roots of the equation. So it doesn't matter, they're all talking about the same location on the graph. So when it comes to the function, it is the x-intercepts or zeros. When it comes to the equation, solutions and roots. Really doesn't matter, just know that they're asking where's it crossing. Alright? Quadratic equations can have 2, 1, or no real solutions. In other words, that graph may cross the x-axis in 2 places, it may only touch in 1, or it may never cross at all. If the function crosses the x-axis in 2 places, there are 2 real solutions, and it would look, let me get a color you can see. Here's my graph, and it would look like that. It's going to cross in 2 places, right there and right there. Those are 2 real solutions. If the function touches the x-axis in 1 place, doesn't really cross but just touches there, then it is said to have only 1 real solution. For instance, it would look something like that where it just touches once. That is 1 real solution. This is called a double root, and you'll see why once we start working with the factors, why it's called a double root. But for now, it's only 1 solution. It just touches, it does not cross at all. And if your function, draw another graph here, if your function never crosses the x-axis, then there are no real solutions. It will look like something hanging up in the air, like that. Never crosses that x-axis. These are only non-real solutions, and you'll learn about those in future algebra classes. So for now, when you have a graph that looks like that, that does not cross the x-axis, there are no real solutions. So your choices are 2, 1, or none. No real solutions. Okay? Alright, so let's do a couple, or actually a few. First one says x squared minus x minus 6 equals 0. And that would be graphing y is equal to that same thing without the equal 0 on the back end. Alright, so when we graph this, we know, just looking at this, you should know that the y-intercept is negative 6. So you should be able to at least go right there and put a dot. 1, 2, 3, 4, 5. Because that's very easy to do. Alright, so when you look at this, if you pulled it up in your calculator and you wanted to graph this, you would type in x squared minus x minus 6 and graph it. And you'll notice that it crosses right here at 3 and negative 2. So you would go right here. 3. Whoops. Why did it drag like that? Let's fix that. That looks horrible. 3 and negative 2. And you can draw your graph. That's a very horrible looking view, isn't it? Okay, so there are 2 places that it touches the x-axis, so that means it's 2 solutions, and the solutions are the place where it crosses. So that would be at negative 2 and positive 3. Now, if they wanted the specific x-intercepts, you would make these into order pairs, and that would be -2, 0. Just remember the x comes first, and 3, 0. Those are the x-intercepts, the actual locations. All right, let's look at the next one. This one says x squared minus 4x plus 4. All right, grabbing my calculator. Well, first let's do our y-intercept. We know where it's going to cross. Plug in 0 everywhere there's an x, and you would get y is 4. So we'll put a dot right there. That's the y-intercept. All right, helps you keep your graph in the right place. And let's go back to y equals and type in x squared minus 4x plus 4. All right, and then graph it. All right, and you'll notice that it touches right there at +2. Okay, and it only touches, one time and doesn't go through. So I'm going to go ahead and graph this. I'm making all sorts of extra marks today. I don't know what's up with that. All right, so go down, touch, and bounce off. Okay, so there is only one place where it touches or crosses. So it's one solution, and the location is at 2. All right, so that would be an order pair of 2, 0. And this is the one that's called, oops, I should have put this down here. Got all excited about it. This is called a double root. And that should have been in the blank right there. Double root. Okay, and then the last one, we want to go ahead and graph that one. And again, you know the y-intercept, if you plug in 0 for the x's, you'll get at 4. Is where it crosses the y-axis. And then you will go and type that one in. Let's move it out of the way so you can see it. All right, x squared, I need to change that to a plus, and that to a 2, and that should do it, right? X squared plus 2x plus 4, yay. Graph it. Now, this one's hanging up there in the air, okay? So, this one is up above here, around in here somewhere. You can find the actual points if you go to your table. Scroll. All right, so at 0, 4, and 1, 7, and -2, 4, -2. There's something in between, so it's going in here like this. Okay? It never touches the x-axis at all, so there are no real solutions or non-real. Same thing. Okay? Now, we are going to be finding other solutions that don't exactly cross at the right, at exactly, a whole number place. Okay, and when you do that, your calculator will do all this for you, but you need to know the sequence and how to do it. To find the solutions for each of these equations, you're going to graph it in your calculator just like I had been doing, and then you're going to use the second trace button, and you're going to choose number 2, which is 0. And then you're going to have to set the left bound, the right bound, and then enter again for each 0 you want to find. So you might have to do it twice. If you had a system like this, you would have to do it twice. All right, just start on the left side of the function and go towards the right, following the curve, whichever way it goes. And then you will have decimal answers at times. And if you do, please round to the nearest tenth. So let's do some so you'll see what I'm talking about. Okay, here's a prime example. I'm going to pull up my calculator, move it out of the way so you can see it. Go to y equals, clear that out. Then I'm going to type in x squared minus 7x plus 5. All right, and then I'm going to graph it. Now you notice it doesn't go across at very nice even places. Okay, it may look close, but it's not. What we want to do is find the exact places. So we will hit second and then trace. And notice it gives you a menu, and you're going to pick number 2 for 0. That's what we're looking for. Now, this one's going left to right, following this curve. So we're going to put our little spider dude up there in the front, up on this side. We want to go above and below this 0. Okay? We'll put, can you see him? He's above, and I'm going to hit enter. And then it says right bound, so you go down below the line. What it does is it narrows the search for this 0 to between these 2 points. All right, hit enter. Then it says guess, just hit enter again. And it'll tell you that this 0 is at 0.807. So round to the nearest tenth, I'm going to say point. What in the world? Why? Hold on, that was horrible. 0.8. All right, now let's go back and do the other one. You have to hit second, trace again, and 2 to do the other side. So you move little spider dude to the bottom. See, we're just following the curve. Okay, so we go above and below, but we're following the curve. This one is going to get to the bottom first, so you hit enter. And then you're going to go above, just so you narrow down the search, and hit enter again. And this one right there is at 6.19, so I'm going to round that to 6.2. 6.2. Okay, that's the place right here and the place right here. These are your solutions. Okay? All right, now the next one, this one has to be fixed because it is not set equal to 0. It's equal to -6. So I have to move that -6 over here. And let's make sure we keep it in descending order. Plus x. And then if we move that -6 over, it's going to become a +6. And now we can graph it. Alright, so go back to y equals, clear that out. Type in, I'm going to have a negative and then I'm going to put a parenthesis. 1 divided by 4 parenthesis x squared plus x plus 6. Make sure I've got all that typed in right. Graph it. Alright, looks like my picture. Very good. Alright, so now I want to find the 0. So I hit second, trace, 2. And now this time I'm going to start over here and go down up because I follow the curve of the parabola. So I got to go below and follow it as I go. Okay, that's the easiest way to remember how to do it. Just follow it. If it goes down, up, and then up, down, that's fine. And it'll be reversed if it's smiley face parabola. So just follow the curve. It's the best way to do it. So left bound and make sure you hit enter and then go above the thing and narrow the search down. Enter, enter. That'll give me a -3.29, so a -3.3. Alright, so I'm going to write, whoa, why is it doing that? It's just messy. -3.3. And let's go back and do the other one. So I'm going to hit second, trace, 2. And I'm going to move over here and may have to hold it for a little bit and just be patient. Don't be smacking on the calculators. It will move. Just hold the button down and little spider guy will go. Okay? Above the line, hit enter. And below the line, and hit enter, and enter again. And this side is 7.29, which is 7.3. All right, in the positive direction. So I'm going to go back here. I knew I was going to do that. 7.3. Okay, so, and you'll look, you can count over, it's about right. All right, so you just follow the curve. Over here, I went and started here and went below, and then moved over and did the other one below and above. So I'm just following the curve. You can just keep that in mind. You'll have no problems with this. And that's all you do to find these curves. Even if it's a whole number, it will give it to you. So if you need to find the solutions, the zeros, the roots, the x-intercepts, that's how you're going to do it. Okay? So we will practice this in class, and we'll talk to you later. See you then.